Hi everyone, welcome to Winpoint online classes. In this session, we are going to discuss force acting on a current carrying conductor, Fleming's left hand rule, questions and answers, motor principle, working of motor. This topic we are going to cover in this session. Thanks for visiting our channel. Force on a current carrying conductor in a magnetic field. What is a conductor? Conductor means it will allow the passage of electricity. When electricity is passing through the conductor, there will be production of magnetic field. We already discussed this topic in the previous classes. If current is flowing through a conductor, there will be production of magnetic field around it. It will be a circular magnetic field. Right? And we can find the direction of that magnetic field using right hand thumb rule, right? Now we are going to discuss the force acting on a current carrying conductor. For discussing this, we need some arrangement. We can discuss it with an experiment. This is a stand. These are conducting wires. Using these conducting wires, we are going to transmit electricity through a conductor. This is the conductor. We are connecting it with the battery and there is a switch. You can see the arrangement now. When electricity is passing through this conductor, what is going to happen? There will be production of magnetic field around it. Around the conductor, there will be production of magnetic field. And we are going to place another magnet near to this conductor. So there is another magnet here now. Now there are two magnetic field. One magnetic field is going to produce because of the electric current. Now switch is off. So no electricity, no magnetic field. And there is a permanent magnet here. This horseshoe magnet. Using this magnet, we can produce magnetic field. Here already there is a magnetic field. When we are switching on, now its switch is on, now there will be flow of current through the conductor. Because of this flow, there will be production of magnetic field. Now there are two magnetic fields. Magnetic field because of the conductor and magnetic field because of the horseshoe magnet. There will be interaction, right? Because of this interaction of magnetic field, there will be a force acting on this conductor. It is known as motor principle. So there will be a force acting on this conductor. It is known as motor principle. So we can write motor principle now. Current carrying conductor in a magnetic field experiences a force. It is known as motor principle. So what is motor principle? The principle is very simple, right? If we are placing a current carrying conductor in a magnetic field, that current carrying conductor will experience a force. Direction of force. Now we need to find the direction of force, right? Force is a vector quantity. Force is having magnitude as well as direction. We can find direction of force using Fleming's left hand rule. You need to hold your fingers like this. Forefinger, middle finger and thumb. These three fingers we need to learn this rule. It's a technique, not rule, it is a technique. Direction of force, Fleming's left hand rule. Here you can see the finger. Just imagine this forefinger, first finger is indicating. First finger means when we are saying 1, we are using this finger, right? 1, 2, right? So this is first finger, forefinger. If forefinger is indicating direction of magnetic field and middle finger is indicating direction of current, then thumb will indicate the direction of force. Very simple though, right? Forefinger is indicating magnetic field, middle finger is indicating current, then force will be indicated by thumb. Thumb is force, right? Now we can write the law. According to this rule, stretch the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular. They are perpendicular each other, right? If the first finger points in the direction of magnetic field and second finger points in the direction of current, then thumb will point in the direction of motion of the force acting on the conductor. This rule is very important. Using this rule, we are going to explain the working of motor. Now let's discuss some of the questions related to Fleming's left hand rule. An electron enters a magnetic field at right angles to it as shown in figure. There is a figure. Electron is entering like this, the perpendicular to magnetic field. The direction of force acting on the electron will be dash. We need to use our Fleming's left hand rule. Magnetic field is in this direction, right? So magnetic field. What about electron? Electron is flowing in downward direction. The flow of electron is in downward direction, but flow of current will be in upward direction, opposite of flow of electron. So we need to hold the finger like this. Magnetic field, current. Electron flow is in downward direction, but current will be flowing in upward direction, opposite of electron flow. What is the direction of thumb now? It is into the paper, right? Into the screen. So direction of force will be into the paper. Next one. Which of the following property of proton can change while it moves freely in a magnetic field? There may be more than one correct answer. Mass, speed, velocity, momentum. Mass is a universal constant. Mass is not going to change. Leave that option. Speed. Is there any change in the speed when electron is getting inside the magnetic field? No, there won't be any change in the speed. The next option is velocity and momentum. What is velocity? Velocity is the speed with direction, right? When a proton is getting inside the magnetic field and it is moving in the magnetic field, there will be change in direction. It will deflect. It will deviate from its original path, initial path. So there will be change in direction. Because of this change in direction, there will be change in velocity. Speed is not changing, but velocity is changing because of change in direction. So velocity is going to change. What is momentum? It is a product of mass and velocity. Mass is not going to change, but velocity is changing, then momentum will change because momentum is the product of mass and velocity. So answer is velocity and momentum. In this activity, how do we think the displacement of rod AB will be affected? Current in rod AB increased, a stronger horseshoe magnet is used, length of the rod AB is increased. We are going to change the length of the rod, we are going to change the power of the magnet, we are going to change the intensity of current flowing through the conductor. What will be the change in the displacement? If we are increasing intensity of current, displacement will be more. If we are increasing the power of horseshoe magnet, displacement will be more. If you are increasing length of the rod, there will be more displacement. So answer is the displacement will increase in all the cases. A positively charged particle projected towards west is deflected towards north by a magnetic field. The direction of magnetic field is dash. This is west. This is east. North, south. You need to know that first. Alpha particle projected towards west. The alpha particle is projecting towards west, right? This is west. Alpha particle is projecting towards west. And it is deflecting towards north. Then what will be the direction of magnetic field? That's the question. Same rule we need to apply. Fleming's left hand rule. There is a alpha particle, charged particle, positively charged particle. It is moving in the magnetic field. It is moving in the magnetic field and it is deflecting, right? It is deflecting in north direction and it is moving in this direction, right? We are going to apply Fleming's left hand rule. It is the direction of current, it is the direction of magnetic field, it is the direction of force. Force is acting in upward direction, that's why it is moving up. What about current? The proton is moving in this direction, current will be also in that direction, right? And what about magnetic field? It is towards you, right? It is in upward direction. Here, this is current, this is thumb, this is force, and it is in upward direction towards you. So answer is magnetic field is in upward direction. Next one is very important topic, electric motor. You all are familiar with DC motors, right? We are going to discuss the working of DC motors here. These electric motors are having lot of application in daily life. The fan, we are using ceiling fan, table fan, mixer, everything is based on this DC motors. We are going to discuss the working of DC motors. Okay. First we can discuss the construction. DC motors are having magnets. These magnets are known as field magnets. These magnets are known as field magnets. You can see the north pole and south pole. And you can see that there are two rings. These rings are known as split rings. Here these are split rings. There are two brushes. So split rings and brushes. So motor is consist of two field magnets, split rings, brushes, and a rotating part. It is armature. It is a rotating part of the motor. It is known as armature. Split ring is connected to the battery, DC battery, and there is a switch also. This is the construction of electric motor. Very important topic. You need to learn to draw this one, and it is very simple. Now we are going to discuss the working of motor. The rotating part of motor is armature. This is our armature. We are going to observe the armature from the top. So the view will be like this, right? It is the armature. Here it is A, B, C, D, right? We are going to mark that points here. A, B, C, D. We are observing it from the top. Okay. And it is the direction of current. When we are switching on the circuit, the direction of current will be, it will start from A, B, C, D, right? It will be the direction of flow of current. Now we are going to observe the direction of force in each side. First we are going to observe the direction of force at this side AB and this side CD. At this side, what is the direction of current? At this side, the current is flowing from A to B. Okay. So we are going to apply the Fleming's left hand rule to find the direction of force at this side AB. What is the direction of magnetic field? Magnetic field is from North Pole to South Pole. Here you can see the magnetic field lines. North Pole to South Pole, it is a direction of magnetic field, it is a direction of current, A to B. If forefinger is indicating the direction of magnetic field, middle finger is indicating the direction of current, then thumb will indicate the direction of force. So we can say that the force here, the force is in this direction, it's towards me, okay, it is towards me. At this side, CD, it is C and it is D. What is the direction of current? Current is starting from here, A, B, C, D, flowing in downward direction. So first we are keeping the finger. What is the direction of magnetic field? It is the direction of magnetic field, but current is in downward direction. If forefinger is indicating the direction of magnetic field, middle finger is indicating the direction of current, then what about force? Thumb will indicate the direction of force. So what is the direction of force? It is the direction of force. It is towards you. Here the force is towards me. Here the force is towards you. It will rotate, right? It is the second half cycle. Now it is second half cycle. In the second half cycle, the current is flowing from DCBA, right? DCBA. With the help of splittering, we have changed the direction of current. In the previous cycle, it was ABCD. Here it is DCBA, reversing of the current. Splittering is doing that. Splittering will reverse the current. Here we are going to apply Fleming's left hand rule. At this side, DC, the direction of current is from D to C. It is the direction of current. And what is the direction of magnetic field? It is from North Pole to South Pole. It is the direction of magnetic field. It is the direction of current, and force is towards me. At this side, force is towards me. Okay. And what about this side? The current is flowing from D, C, B, A. It is the direction of current. And magnetic field is from North Pole to South Pole. It is the direction of magnetic field. And this is the direction of current. The force is towards you. Here the force is towards you. Here force is towards me. It will continue its rotation. It is a working of electric motor. Electric motor consists of two field magnets, an armature, split rings and brushes. When electricity is passing through the armature, it will experience a force and it starts its rotation. Split rings reverse the current through the armature and it gets continuous rotations. This is the working of electric motor. If you like this video, please subscribe to my channel and thanks for watching.